This is massive. The SpaceX Starship flame trench is rapidly coming together. Let me hear from you. Were you caught in traffic behind 350 cement trucks? Mission prep for Rocket Lab to Venus is heating up in more ways than one. We are talking about Phobos and Deimos again. No, not the floating launch pads, but the actual Martian moons. And asteroids. Are we making the same mistake the dinosaurs made? My name is Felix, welcome to What About It, let's dive right in. SpaceX's pad is taking shape before our eyes. Its standout feature, its new enormous flame trench. We still aren't quite sure why Pad A didn't initially have one of these, and it's easy to find reminders of Flight 1 in the flats and dunes around the launch site. Some would just call it material testing, I guess. But with Pad B, SpaceX isn't leaving anything to chance, and as we've shown you before, the trench is coming together almost faster than we can document it. Currently, hundreds of cement trucks and pumps are conducting a giga-scale pouring operation to finish the floor of the trench at Pad B. Shots taken last week by our aerial scout Jordan Guidry showed that the workers had finished laying rebar on its floor, with both ramps of the trench and other signs pointing to the imminent concrete pour. Our estimates on when Pad B will be used to support an actual full Starship launch are still months out, but the pad is growing closer to what looks more and more like a state where it can support a ship catch operation. Here's to looking at Flight 9, Ship 35 and Booster 16. Or 14, just saying. We currently have no timeline for these launches beyond this post just after Flight 8, which said 4 to 6 weeks from that day. It seems they set a rough timeline heading for mid to late April. Elon time or real time? I honestly don't know yet, but the past shows that SpaceX can make these things happen. We'll keep you posted on all of the Pad B developments as they occur if we can keep up with SpaceX. Don't worry, we will. Is Block 2 cursed? Many have wondered what is causing the snag in Starship development. Will the Starship team revisit elements of the Block 1 program, where the ships seemed nearly indestructible and put on several incredible displays of resilience through re-entry? Recent observations at the production site have shown Ship 36 and 37's nose cones are now nestled in Mega Bay 2. While Ship 36's nose cone looks to be completely tiled, we can see that Ship 37's nose cone is less so. Some have speculated that SpaceX could just be pushing these future Block 2 ships out faster to expedite the move to Block 3. But that's just that, speculation. It remains to be seen if any vastly different changes will be made to Ship 37 compared to its two predecessors. Flight 9 remains the most important test currently. Yet all this definitely makes their path forward interesting. How did Block 1 starships fare so well, but Block 2 variants haven't even made it to engine relight yet? There's a lot of talk about why SpaceX just launched two starships producing the same problem. Did they not even try to fix the issue that plagued Flight 7? The answer is pretty easy. They absolutely did. Big differences separate both ships 33 and 34, it just didn't fix the issue. That's the goal still, and SpaceX will try everything to make it count again. They are the ones who want these ships to succeed even more than we do. Rocket Lab has partnered with MIT for the first privately funded mission to Venus, now scheduled for no earlier than summer 2026. We've talked a lot about how this project aims to deepen our understanding of Venus, a planet we've often overlooked due to its harsh conditions. But one that's become increasingly intriguing as we're exploring the possibilities of life in the rest of our solar system. Cloud City on Bespin vibes, anyone? The key component that is central to this mission is a compact atmospheric probe. It's built to dive into Venus's dense cloud layers and gather critical data, such as temperature and chemical composition of the clouds and other atmospheric data at a scale never attempted before. It would be nice if the sulfuric acid levels weren't quite as high up in the clouds as they are on the surface. And while we're at it, maybe we can dial the atmospheric pressure down a bit too? It's fitted with an autofluorescing nephelometer. Say that 5 times fast. This is a sophisticated tool with a complex name. Simply put, the probe will search for organic compounds, the key indicators of potential life. As it navigates through the acidic clouds and intense pressure, it will transmit findings that could reshape our view of Venus, hinting at whether life might survive in the middle zones high above its volcanic surface. Recently, phosphine was detected in the Venusian clouds. This is something that is typically found here on Earth as a result of anaerobic processes. That is why this mission is so interesting in the first place. While the mission promises to be exciting, the challenges of getting to Venus are immense. Entering its atmosphere is like diving into a furnace while getting hit with acid rain. Like real acid rain, as in it's actually acid that is raining on you. Thankfully, that's where a key innovation comes in that the teams have developed. The heat shield for extreme entry environment technology, or HEET, developed by NASA's Ames Research Center. It's a true engineering marvel, woven from materials that can withstand temperatures of up to 2,482 degrees Celsius or 4,500 degrees Fahrenheit. That's just slightly hotter than the boiling point of aluminum. You heard that right, not melting, boiling. Imagine a spacecraft screaming through the atmosphere, glowing red hot while the heat stands firm, protecting the probe inside from being incinerated. This is soon set to be a reality. It's a testament to human ingenuity ensuring the mission can survive the fiery plunge and deliver its payload to the clouds below. The journey begins aboard Rocket Lab's Photon spacecraft bus, a versatile platform that's already proven its chops in Earth orbit. Photon will serve as the interplanetary chauffeur for this mission, carrying the probe on a months-long trek across the solar system to Venus. Once it arrives, the probe will detach and begin its daring descent while Photon watches from above. During the mission, the probe will take detailed measurements of the atmosphere, its chemistry, its structure, and its quirks, offering scientists a treasure trove of data to unravel Venus's past and present. And maybe even hint at its potential for habitability. This isn't a spur-of-the-moment adventure either. Originally planned for an earlier launch, the mission was pushed back to summer 2026. Rocket Lab and MIT are fine-tuning the technology, coordinating logistics, and ensuring the probe is ready to tackle one of, if not the harshest planetary environment in our solar system. When it finally launches, this mission will mark a historic milestone. It will be the first private venture to another planet and a bold step forward in the era of commercial space exploration. Here's to more private expeditions to other spots in our solar system. If you could pick a destination, what would it be? Let us know in the comments. Asteroid 2024 YR has been making waves. Few come this close to Earth. With stories like this, misinformation spreads fast. That's why I use a trusted tool to cut through the noise. Let's see what the media is saying. Join me at ground.news/y. At first glance, it might seem like massive destruction is inevitable in 2032. The asteroid, often called a city killer, is depicted as a giant rock shattering Earth's crust. But if you care to take a second look, you will find reporting media painting a very different picture. The record-breaking probability of this asteroid hitting the Earth after a jump to a 1 in 32 chance, the highest impact probability NASA has ever recorded for an object of this size or larger, new data has dropped those odds to a 1 in 67 chance. Another observation is that the reporting on the possible damage caused by a potential impact differs noticeably. Ground News found over 200 sources covering this, with more than 80% rated highly factual, showing accurate reporting and timely corrections. Many headlines still lean towards sensationalism. That's just how the media works. Bias is everywhere, just like in this example. While one newspaper's headline read, "City killer asteroid could wipe out 100 million people in 7 years," things were stated in a much more factual manner in another. A headline on the same topic calmly asked, "Asteroid 2024 YR4, is it threatening Earth?" You can stay ahead of sensationalism with Ground News. It's subscriber funded, meaning no ads or clickbait, just clear factual reporting. Go to ground.news/y or scan the QR code for 40% off unlimited access, the same plan I use. That's ground.news/y. Get the whole story, try it for yourself. From Venus, we head over to our other neighbor, Mars. The Martian Moon's Exploration Mission, or MMX, is JAXA joining forces with NASA, Germany's DLR, and France's CNES for a deep dive into, you guessed it, Mars's moons Phobos and Deimos. It's set to blast off in late 2026. This isn't just a flyby, there is detective work involved. The question's been nagging scientists forever. Where'd these moons come from? Are they rogue asteroids Mars snagged with its gravity way back in the day, or are they bits of the red planet itself smashed off by some huge impacts billions of years ago? MMX is built to settle that debate, and it's got a plan that's just crazy enough to work. The spacecraft is a beast, packed with spectrometers to sniff out minerals, high-resolution cameras for detailed pics, and a dust monitor to catch whatever's floating around out there. Once it gets to Mars in 2027, it'll settle into orbit around Phobos and Deimos, snapping photos and scanning their surfaces to figure out what they are made of. Rock? Ice? Maybe something weirder? But the real show starts on Phobos. This one is the bigger one, at about 22 kilometers across, and it's all scarred up with craters, like Stickney, for example, which is a giant 9-kilometer pockmark. MMX is going to land there and use a precision corer to scoop up at least 10 grams of its dusty, rocky surface. Here comes the sensation. It will be transported back to Earth by 2031, and when it lands, labs will be looking for traces of the solar system's early days, maybe even organic compounds or hints of life's building blocks locked inside the precious dirt. Yes, we're actually taking samples from other planets' moons. It's weird to say that, but there's even more. The mission is dropping a little rover, created by DLR and CNES, right onto Phobos' surface. This moon's gravity is about 1/1000th of what we experience here on Earth, so the rover is probably going to do more hopping than rolling. As it does this, it will be testing the ground's texture, temperature, and how solid it is, feeding intel back to the main craft for the sample grab. It's a pathfinder in a sense, as it will be figuring out how to move on low-gravity worlds. Imagine trying to walk, but every time you set a foot down, it makes you float. This is stuff we need to know for future missions to asteroids or other moons. Meanwhile, from orbit, MMX will turn its gaze to Mars itself. Its thin atmosphere has been leaking into space for eons, and over months of observation, the spacecraft will track how that has stripped away water and possibly once habitable conditions. It's like a side quest that could help us understand or even rewrite Mars's backstory, bonus points. So why choose Phobos or Deimos over Mars itself? Phobos' gravity is so light that landing and launching back into its orbit is a breeze compared to Mars's much stronger pull. Plus, it's close to Mars, orbiting just 6,000 kilometers up. That's 50 times closer than our moon is to Earth. It might be dusted with Martian rocks kicked up by ancient asteroid strikes. That means MMX could snag Mars samples indirectly without ever touching the planet. Deimos is smaller at 15 kilometers wide and further out at 23,000 kilometers from Mars. It will get attention as well, but Phobos is the main event. After arriving in 2027, MMX will spend a solid year poking around, orbiting, landing, and sampling before packing up and heading home. If the collected samples have water traces, organic molecules, or even signs microbes hitched a ride long ago, it's a big deal, not just for Mars moons, but for how planets and their satellites come together. Imagine pulling off a landing, digging up a sample, and rocketing it back from deep space. That's a first for Japan and a huge step for anyone eyeing further out targets like Jupiter's moons. We're excited about a potential launch late next year with arrival in 2027 and the trip back home in 2031. MMX could reveal a new side to the Martian system's past and show us how life's ingredients might have spread around the cosmos. Hopefully, in the future, we can get more detailed images of planets and moons than ever before. If you liked seeing stuff like this in high detail, you can help us out in covering them. Help improve the channel and double check that you've hit the like and the subscribe button to stay up to date with our updates. It's free and it helps us bring you even better content. Thank you. Here's another take on Deimos. A recent mission just gave us the clearest ever photos of that moon. The Hera mission, launched by the European Space Agency last year via a SpaceX Falcon 9, is a key piece in humanity's plan to deflect asteroids. Its destination is the Didymos system, a near-Earth binary asteroid pair that contains Didymos at 780 meters wide and its moonlet Dimorphos at 151 meters wide. How's this relevant? Well, Hera needed a gravity assist around Mars to get there, and it took some pictures on the way. As it was doing a 1,000-kilometer flyby of Mars, it imaged the planet and one of its moons, Deimos, with its high-resolution cameras. Because why not grab some data while you're there? The Deimos photos from Hera's March 12 flyby are historic. They are the first images from Hera's instruments, the asteroid framing camera, Hyperscout H, and JAXA's thermal infrared imager beyond Earth and the Moon. While passing as close as it did, Hera imaged Deimos' far side, rarely seen due to its tidal lock with Mars. The black and white camera achieved a 100-meter resolution, clearly showing craters and dust. Hyperscout H mapped minerals in 25 spectral bands. The thermal imager revealed surface temperatures which contrasted Deimos' infrared brightness with its visible faintness. Unlike prior glimpses from Mariner 9 or Mars Express, Hera's multi-instrument high-speed snapshot shows many previously unknown details on this 12.4-kilometer moon. Its main objective follows NASA's 2022 DART mission. It slammed into the asteroid Dimorphos, cutting its orbit around another asteroid, Didymos, by 32 minutes. Its task is to analyze the impact's effect, crater size, mass changes, and structural makeup to refine this kinetic deflection strategy. It's like a sniper shot, but the target was so far out that you have to send someone to see how you hit. Basically, Hera is seeing if we broke anything, or to better understand if we can boop asteroids with some actual boomph. Hera also has two CubeSats, Melani and Juventus, set to deploy at Didymos. Melani will study surface composition, while Juventus will use radar to probe Dimorphos' interior. Is it solid rock or loose rubble? That answer shapes how we nudge or boop future threats. Can we rename Armageddon to Boopageddon? Hera is a vital part of planetary defense techniques. Near-Earth asteroids like Didymos aren't abstract risks. Collisions have happened before. Ask the dinosaurs. Oh wait, you can't. Hera's data will clarify how darts impact altered Dimorphos and what it takes to redirect similar objects. It's set to cruise for 2 more years with a tweak in February 2026 before orbiting Didymos for 6 months. It'll map the dart crater to 10 centimeters precision and measure mass via gravitational wobble, possibly ending with a landing. 10 centimeter precision on a distant asteroid moonlet is honestly just completely insane. We don't appreciate engineers enough. A lot of you joined our community to learn more about asteroid booping and other similar endeavors, and we are still growing in numbers today. If you appreciate the content, become a channel member or a patron for extra content. Secure your access to up to 7 picture galleries per week, satellite, aerial and ground photos, and 3D animations. The resolution is even better than 10 centimeters. Chat with us and gain more insights on the topics you love. Thank you so much for your support. Imagine a trio of tiny spacecraft no bigger than carry-on suitcases streaking through the night sky. Their sights are set on unraveling one of Earth's most dazzling yet elusive mysteries. This is NASA's Electrojet Zeeman Imaging Explorer, or EASY. It's a mission that blasted off under the starry California sky last week atop a SpaceX Falcon 9 rocket from Vandenberg Space Force Base near Santa Barbara. These 3 CubeSats are now on an exciting quest to decode the secrets of auroral electrojets, massive electric currents that surge through our upper atmosphere and ignite the polar skies with the glow of the northern and southern lights. A CubeSat is a very tiny form factor for a satellite, cost-effective and quick to build. These electrojets are the hidden forces driving auroras. Yet they also pose unpredictable risks to our technology-dependent society, potentially disrupting satellites, damaging power grids, and exposing astronauts to danger. The 3 EASY CubeSats represent a feat of engineering and coordination. Orbiting Earth at an altitude between 420 and 600 kilometers, they travel in a sequential formation spaced out like a chain of pearls. These compact satellites leverage atmospheric drag to adjust their distances, passing over the same polar regions at intervals of 2 to 10 minutes. Each is equipped with a microwave electrojet magnetogram. It's a sophisticated instrument developed by NASA's Jet Propulsion Laboratory. With 4 angled antennas, the CubeSats detect the magnetic signatures of electrojets imprinted in oxygen molecules below, offering a detailed glimpse into these atmospheric phenomena. It's a technique rooted in the Zeeman effect. The what? Put simply, it splits light to reveal the current's strength and shape, all from a tricky altitude too high for balloons and too low for satellites to linger at. Those electrojets are part of a vast circuit, stretching 161,000 kilometers into space, linking our planet to the solar wind's fury. By mapping their twists and turns, EASY will help scientists predict space weather and those geomagnetic storms that can fry electronics or plunge entire civilizations into darkness in the worst case scenario. Yeah. Back on Earth, the mission team is handing out EASY Mag kits. Mini magnetometers for students, teachers and science buffs to measure these currents from the ground. Launched in the thick of solar maximum when the sun's activity peaks, EASY is perfectly timed to catch the electrojets at their wildest. ESA Aerospace is launching the first test flight of its Spectrum rocket from Andøya spaceport in Norway. They just got their launch operator license from the Norwegian Civil Aviation Authority this month. This was the last big hurdle before gearing up for a potential launch. This is the first orbital launch vehicle liftoff from continental Europe, a milestone for this now 7-year-old private company. Dubbed Going Full Spectrum, the mission is not carrying customer payloads this time, but if it all goes according to plan, that will come later. Spectrum is a 2-stage rocket built to haul small and medium satellites up to 1,000 kilograms into low Earth orbit. ESA Aerospace has been working toward this for years. Last month they successfully conducted static fire tests of both stages, including a 30-second burn of Stage 1's 9 Aquila engines on February 14th. Also, ESA Aerospace has built everything for Spectrum in-house, from the engines to avionics, with a team of more than 400 people from 50 countries. Andøya is a uniquely special launch location with an inclination of 69 degrees north off Norway's coast. It offers clear shots of the ocean for polar and sun-synchronous orbits. ESA Aerospace has secured sole use of Andøya Spaceport's first launchpad, a state-of-the-art facility equipped with a control center and payload integration setup. The company raised over 400 million euros from private investors to drive this effort, which aims to give Europe an independent launch capability. Couldn't make the hop across the pond to see this exciting European launch? What about a hop across the channel in Brownsville? Check out redlineheli.com/Felix for a once-in-a-lifetime experience and $25 off flying in a helicopter above Starbase. The Redline helicopter team is waiting for you. They'll show you the same views our photographers get on their Starbase flights. It's incredible. Butch and Sunny are back on planet Earth 9 months after arriving on the International Space Station via Boeing's Starliner, which eventually returned home uncrewed due to a litany of technical issues. To resolve the travel problem, NASA decided to integrate them into Expedition 72, which extended their mission to approximately 286 days. SpaceX's Crew 9 mission, launched September 28th last year with the Crew Dragon Freedom, became their return ticket. Crew 9 originally planned for 4 astronauts to return, but NASA changed it to 2 and reserved seats for Wilmore and Williams. This adjustment dropped Xana Cartman and Stefanie Wilson from the manifest, and no current return timetable for them too is set at this time. It's kind of like that game where you always have one seat missing and everybody needs to sit down quickly, but then in the end one is left without a seat. It just feels good to have the 2 astronauts home again. We'll talk about this in detail in a future episode, but it might actually be that Starliner gets a 3rd chance. Do you think it deserves another chance? Let me know in the comments. That's it for today. Remember to smash that like button, subscribe for more. This is what fuels the algorithm, and this is how you can help us for free. Check out our epic shirts in your favorite Space Nerd store. A new Raptor design and our brand new Starship Block 2 design are both up. Link is in the description and in the card you should see now. Also, check out our print store at shop.whataboutit.space to buy a picture for your favorite wall. A significant amount of every purchase goes directly to our photographers. And if you want to learn more about the fascinating story of SpaceX's Raptor 3 engine, watch this video next to continue your journey. Thank you very much for watching, and I'll see you again in the next episode. The Heeet stands for a giga scale nephelometer. Nephelometer. It's scrolling. Didymos.